All right, today we're going to use what we learned yesterday about making the 5-number summary in order to make a box and whisker plot. So we did a lot of the hard work yesterday, finding the actual 5 numbers that are in the 5-number summary. Today we're just going to put those numbers to use in order to make like a diagram, a visual of those 4 quartiles of our data. Okay, so a box and whisker plot represents a data set along a number line by using the 5-number summary of the data. A box and whisker plot looks something like this. Okay, so here we can see all of our 5 numbers. So here we have the least value, that's what we call our min, our first quartile, Q1, our median, Q2, our third quartile, Q3, and our greatest value, our max. So that's where all of those 5 numbers that we learned how to find yesterday are incorporated into this graph called a box and whisker plot. It's called a box and whisker plot because, as you can see, there's a box, and then those represent our quartiles, and then going out to our max and out to our min are like those little whiskers. Okay, so let's learn the steps on how to make one. First, we're always going to write that data in order from least to greatest, if it's not already. Okay, in some problems, I'm just going to give you the 5-number summary, like the example below, and then just have you make the box and whisker plot. But sometimes you're going to have to find the 5-number summary and then make the box and whisker plot. So these are the steps for if you have to find the 5-number summary, if you're given the 5-number summary and just have to make it. Right. So the first step of a box and whisker plot, just like a line plot, is to draw that number line that can show the data in equal intervals. Just like a dot or line plot, you have to count by something on your number line. You can't just put like 1, 3, 12, 15, 39. It has to be counting by like 1s or 2s or 3s or 4s, depending on your numbers. Okay. The very first thing we're going to do after we draw that number line is mark the median, which is our Q2. Okay. Then we're going to mark the median of the lower half, which is our Q1. So let's follow along actually with this example down below as we do this. So we draw a number line. That was already given to us, and notice how they're counting by tens. We don't have to start at 0. We could have just started at 10, and we didn't have to go all the way up to 100 because these are our numbers right here. We could have just stopped at that last number, but it's okay to keep going also. All right, so here we have a Q2 of 40, so we're going to put a dot where that Q2 is. That was that step. Now we're done. Now we're going to mark the median of the lower half. We're going to find that Q1. It says the Q1 is 20, so we're going to put a dot where that Q1 is. The next thing we're going to do is find the median of the upper half, which is called our Q3. Okay, so our Q3 up here is 50, so we put a dot where there's a 50. Okay, then we're going to mark the greatest number, the max. Our max is 65, and that's going to go right in the middle of where 60 and 70 is. Notice how I'm making all these dots like on the similar height. That's important because we want them all to be able to like connect to each other in a minute. Then we're going to mark the min, which is our lowest number. Our min is 10. Okay. Now that we have all of our 5 numbers plotted, we have to make the actual box and whisker. So we draw a box around or between Q1 and Q3 so that it will look something like this. Okay, if this is where our Q1 is, this is where our Q3 is, we draw like a line in between them and then connect it over for a box. So that's where we get our box from the box and whisker. So this right here was our Q1, so we draw a line, Q2, Q3, and we connect them to make the box. Okay. Then we draw a vertical line through the median, the Q2. So we just draw that line straight down there. Lastly, we draw two horizontal lines, which are our whiskers, from the rectangle, that box, to the min and the max. Okay, so this was our whiskers from the picture above. We just draw from that dot out to our min, from this dot out to our max. And that is a box and whisker plot. All right, so let's try another example. This one we have to make our number line. Okay, we have to make sure our data is least to greatest. It's not, so the very first thing we have to do is list it least to greatest. Okay, so we should have 14, 15. Looks like the next one is 20 and 26, 27, 30, 30, 30. And 33, 35, 36, and 38. So now we have an example where we weren't given the 5-number summary. So notice how up here you were given those numbers, which makes it pretty simple. There's not many steps to actually make the graph. Oops, I did not mean to do that. All right, well, we're just going to ignore that. So up here you were given the 5-number summary. Down here you have to actually find it. Okay, so our min is 14. That's our smallest number. Our max is 38. That's our biggest number. Once we find the max, we then find our Q2, our median. So I'm going to use a different color. 1 and cross off until I get to the middle. I am left with two 30s in the middle. When I'm left with two of the same number in the middle, and I add them together and divide by 2, I'm going to end up with that same number. Okay, so 30 plus 30 is 60, divided by 2 is 30. So our Q2, remember, is our median, which is 30. When I'm left with two numbers in the middle, the left one goes in our lower group, with our left group. Our right one goes with our upper group, our right group. Okay. Then I'm going to take a different color, or I'm going to cross off the opposite way. To find the median of the lower half, I'm left with two numbers, 20 and 26, so I would add them together to get 46, divided by 2 to get 23. All right, too big to squeeze it in there, so I just pulled it out. And then I do the same thing on the other side. Cross off, cross off, cross off, cross off. I've got my 33 and 35, so I would add those together. I would get 68 divided by 2, and I would get 34. Oops. Is my Q3. Now that I have my 5-number summary, I can start by making my number line. My smallest number is 14. My biggest number is 38. Okay, and we don't have to have a tick mark for every single number here, because notice how when we had a 65, we just put it between the 60 and 70, and that's okay. All right, so I'm going to start counting, let's say with 10, and I'm going to count by 5s. Okay, so I'm going to have 10, 15, 20, 25, 30, 35, and 40. My biggest number is 38, so I can stop at 40. My smallest number was 14, so I had to start at like 10. I couldn't have started at 15. And I knew that that range of those numbers was pretty big, so I wanted to count by something bigger than 1, because otherwise that would take us forever to have to do that. Okay. Now we're going to plot our 5-number summary with dots on our, or above our number line. So we have our min is 14. That would be right around here. Our max is 38. That would be right around here. Our Q1 is 23. That would be right around here. Our Q2 is 30. We have that. And then our Q3 is 34, which would be just right before the 35. Okay, now another way to do it, instead of following these steps up here, you could get rid of those whiskers right away. So our dots on the very outside, we would just connect them in. Okay, so if we're having a hard time remembering where we're making that box around, you can always draw those whiskers first and then know that the box would go around the rest of it. So it's just another way if we're having a hard time of remembering where to put that box. Then the very last thing we do is just draw that vertical line straight down through our Q2, our median. Not too bad. All right. So we not only have to know how to make these, but we have to know how to read them, how to pull information out of them. Okay. And like we said before, our 5-number summary splits our data into quartiles. So 4 parts of data. Okay, now I'm going to draw on this picture, or actually, let me draw next to it so that I don't mess up. Actually, I'm going to change my mind. I'm going to draw up on here. You do not need to draw this on there. You just need to follow along. Okay. Here we have one of our numbers in our 5-number summary. Here we have another one, another one, another one, and another one. In between those spaces, we have 1, 2, 3, 4 parts. Okay, now they don't look equal, but they are an equal amount of numbers. Okay, so for example, when we split that data into groups, okay, so here was our Q1, Q2, and Q3, min and max. Okay, so these are basically these green lines that are down here, but just in our list of numbers. Okay, notice how there's 3 numbers in this group, 3 numbers in this group, 3 numbers in this group, 3 numbers in this group. So we split up our data perfectly even so that there's the same amount of numbers inside each group. Okay, that's why I'm saying that these are 4 equal parts, even though they don't look equal, because there might be, like for example, 34 and what was that number? 38 are closer together than, let's say, 14 and 23. There's more numbers in between 14 and 23 than there are up here. But there's still 4 equal parts because there's still just 3 numbers in our data set that are in that group. Okay, bear with me. I know that this is kind of confusing. Okay, so when I ask you, like, what percent of our data or what fraction of our data lies in this piece right here, since they're 4 equal parts, this would be 1/4 of our data. Okay, because in this list of 12 numbers, 3 of them are in this first quartile, which is 1/4 of the total amount of numbers we have in our list. Okay, same thing would go for that next group. Use a different color. That next group would also be 1/4 of our data because it's still just 3 numbers. Then our next group would also be 1/4 of our data because it's 3 numbers out of the 12. And then last but not least, we have another 1/4 of our data, those 3 numbers. Okay, even though they don't look even, they each only have 3 numbers from our data set inside them. Okay, so down below, when they ask what fraction of the dunk tanks require at least 500 gallons of water. Well, first let's read. The box and whisker plot represents the number of gallons of water needed to fill different types of dunk tanks offered by a company. So a dunk tank, if you've never seen something like this before, might have might be at like a fair, something like a carnival, something like that, where you're trying to throw a ball to hit the target and then their seat would fall out from them and then they get dunked in the water. Okay, so this is talking about the amount of water that this tank needs to be filled in order for it to work. So what fraction of the dunk tanks require at least 500 gallons of water? At least 500 means 500 gallons or more. Means that would require at the least amount 500, but it could be more. Okay, so let's look onto our box and whisker plot where we see 500. And we want 500 or more. We want what fraction of the data is that? Okay, so let's think. If each of these 5 numbers in our 5-number summary splits it into fourths, so this would be like 1/4, This would be 1/4, and even though it doesn't look even, remember it's the same amount of numbers that are in our data set. Just like above, these don't look even, but every single group only had 3 numbers in them. It just depends on how close or spread out they are. Okay, so each of those pieces is 1/4. Now we were looking at 500 or more. So here we have 1/4 of the data. Here we have another 1/4 of the data. So the fraction that would be 500 or more would be 2/4, or if we simplify that, would be 1/2. So that means that half of the dunk tanks that this company offers requires 500 or more gallons of water. Okay. All right, I know this is tricky. Letter B. Are the data more spread out below? So spread out means that there's like a more space. Spread out below the first quartile or above the third quartile. So I'm going to erase what I drew on here so we have a fresh picture to look at. And we're looking below the first quartile and above the third quartile. So min, Q1, Q2, Q3, max. Okay, and it's before the Q1, or yep, below, so that means smaller. And above the third is this way. Well, we can visually just look at those lines. Okay, we want the one that's more spread out. Well, we can tell that this line is bigger. Okay, it's longer than this one. So this one, so above the third quartile is more spread out because it's a longer line. Or you could look at the numbers. So here we have 600 to 750. That's a difference of about 150. Okay, here we have 450, and here we have 350. That's only a difference of 100, which is why the line is shorter. Okay, so they're more spread out up here because there's a bigger distance in between those two numbers. Last but not least, this question is going to ask us to find and interpret the interquartile range of the data. So that's that quartile range. Okay, to find that quartile range, we take Q3 minus Q1. So in our graph, we can pick up Q3, min, Q1, Q2, Q3 is 600. Min, Q1 is 450. Remember, it's Q3 minus Q1. Biggest quartile minus smallest quartile. So we take 600 minus 450, and it would be equal to 150. Okay. All right, I know that that lesson was tough, but it's just adding on a little bit more, creating that box and whisker plot than what we learned yesterday.